Good evening. Good evening, ladies and gentlemen, and thank you very much for joining us this evening. My name is John Hilton. I'm the Chairman of the Formula Student Organising Committee here at IMechE, and it's my great pleasure this evening to welcome our friends and colleagues from Motorsport magazine who've coordinated what's going to be, I think, a really exciting evening this evening, together with our honoured guests from the motorsport community. Two of them really strong supporters of the Formula Student competition as well, which is really nice to see. And I think we're going to have a great evening and get a really interesting insight into the 2014 new regulations and how that championship might work out. Nice and early, maybe enable you all to go and place a bet on who's going to win in 2014. Something I always like to do, a bit of a flutter before it starts. So the first thing I need to do before we get started is to make the general housekeeping announcements. For your safety and as part of the health and safety policy of this institution, we're required to tell you what to do in the case of an emergency. On hearing a fire alarm, please leave this hall immediately by the central doors on this side, or there are alternative doors here and at the back corner. If you can, make your way out the front of the building, turn left, head down the road past the end of the building to the end of cockpit steps, which you'll see are turning on the left with some steps up. That's the place where we muster, as it were, where we gather to check that everybody's present. To prevent interference with microphones and obviously for the benefit of everybody, if you can make sure your mobile phones are switched off or at least turned to a silent mode, that would be greatly welcome. And the consumption of food and drinks is not permitted in the lecture theatre. So those are my notices. So it's now my great pleasure to introduce Ed Foster, who's Associate Editor at Motorsport magazine, who will be the compere for this evening's event. Ed, thank you very much.
Hello everyone, and another very warm welcome to the Future of Motorsport evening, organised by Motorsport and Formula Student. I'm Ed Foster, and I'm going to be hosting this evening. I promise I won't be talking too much because I've got three much more interesting people who are going to join me on stage. I'm not sure if anybody knew this when they organised this evening, and knowing Formula Student and Motorsport they probably did, but in 9 months to this day exactly, on March the 17th, if the Formula 1 calendar is to be believed at the moment, cars will be lining up on the grid in Melbourne, having undergone the biggest rule change in the sport's history. So what's going to happen? We're going to lose the 2.4 litre V8s. We're going to get 1.6 litre not normally aspirated, direct injection turbo V6s. There's going to be much more powerful energy recovery systems as well. At the moment, 80 brake horsepower kinetic energy recovery systems, and that's going to increase to 161 brake horsepower energy recovery systems. And they can be used for 33.3 seconds a lap rather than 6.7 at the moment. What's more, the maximum energy that you can harvest from these is going to rise from 400 kilojoules to 2 megajoules. And the maximum energy you can use, I'm struggling to keep up with this as well, so don't worry if you're not, if you are as well, it's going to rise from 400 kilojoules to 4 megajoules. Now, as the name suggests, we've lost the kinetic from the kinetic energy recovery system. That's because not only will there be kinetic energy recovery, but there'll also be H energy recovery system. We'll be learning more about that from Andy in a bit. Now, add to all of this, the teams are only allowed to use 5 engines for the season rather than 8. And it's quite easy to see the mountain that these guys have had to climb over the last few months, and indeed carry on to climbing for the next few. Now, Formula 1 has always historically run to a set of technical regulations that they've set. They didn't really care too much about the wider world, but that is all going to change next year. Next year, it's all about the wider world. First signs are very good. Honda is coming back into the sport in 2015 as an engine supplier. But there are still some that are saying they're too expensive and we don't need these rule changes. Hopefully, we'll put that to rights later. So here we have Andy Cowell, the engineering director at Mercedes-Benz High Performance Engines. We have James Allison, the recent technical director of Lotus Formula 1. And we have Gordon Day, operations director at Williams Hybrid Power. As I'm sure you all agree, we couldn't have 3 better people for this evening. Now, another small bit of housekeeping. When you came in, you were all handed small voting cards I'll be asking questions to the floor as we go through during the Q&A, and we can use your answers during our discussion. I managed to use it earlier on, so hopefully that means everyone else can as well. And also, we'll be opening the discussion up to questions from the floor afterwards, so do think of some questions, especially if I miss anything on stage, and you will have an opportunity to ask them at the end. One last thing, we are actually part of a webinar this evening. It's a word I first heard about an hour ago, and that means we have two cameras, one down here and one up there, which is recording everything that's happening, and that's streaming live to the internet. We have people watching it from all over Europe apparently, and they too can ask questions. So just to set that straight. Right, well let's get going. Can we please welcome Andy and James and Gordon onto the stage.
Well, Andy, I've touched on it just there. Formula One regulations undergoing a huge change. From, let's say, from someone actually inside the sport, why is Formula One doing this?
I think if we look at the regulations that we've got today, that we're racing with today, the 2.4 litre V8 engine, naturally aspirated. It's an engine that came into Formula One in 2006. That's when we changed from the V10s, took two cylinders off and dropped down to the V8s. At that point, the way power was controlled was through the capacity, and there wasn't an RPM restriction at that point. So in 2006, we had several of the manufacturers running at over 20,000 RPM and chasing to go faster and faster and faster. And with a naturally aspirated engine, the key way to get more power is just to rev it quicker, to pump air through it, because there's no restriction on the fuel flow. There's no restriction on the amount of fuel that you use. Since that point, we've been capped to 18,000 RPM. It dropped to 19,000 and then down to 18,000. And we're left with an engine where fuel consumption in qualifying, there's no regard to that. It's all about power delivered to the track. During the race, there is a concern about the fuel used because the start weight is heavily governed by that and the pace of the car in the opening few laps. But what we wanted to do was, and led by the FIA, was to change to end up with a set of regulations that are more aligned with the way road car development is going. If I look at the development meetings that had, say, 5 years ago with the Mercedes R&D facility, when we talk about a high revving naturally aspirated engine, they're mildly interested, but then we have pleasantries and there's no more technical dialogue. Where we're going to is, as you described it, a regulation where it's fuel flow that counts. And in our everyday lives, that's what matters to us. What matters to us when we buy a road car is how far will it go on a tank of fuel and how much is that tank of fuel going to cost. The regulators around the world control that by the amount of CO2 that's emitted per kilometre that you travel. So the FIA, with the support of the manufacturers, came up with a set of regulations where it's not about airflow pumped through the engine, it's about the fuel consumed. And there are two key numbers that are coming in. One is there's a maximum fuel flow rate, and that's been set at 100 kilograms per hour. And that's about 2/3 of what we run today. And to do a race distance, it's 100 kilograms maximum that you can use from red lights out to seeing the checkered flag. And that again, today we're probably using about 150 kilos, just to pick a round number. So a huge percentage reduction in the fuel used per race and the maximum rate that you can spend that, the flow rate. In racing, you never want to go slower. You don't want to introduce something that goes slower. So we need to introduce some technologies to enable us to get better thermal efficiency. And that's where, following the road car direction of downsizing, down speeding to help with mechanical friction, but then permitting boosting systems to improve the thermal efficiency, and as you mentioned it, the heat recovery system to recover waste energy from the exhaust, and a larger kinetic energy recovery system. We believe we'll get to the point where our lap times are similar to today, but the fuel consumed will be significantly less. So it's a set of regulations that will drive us to have technology development paths which are aligned with road car, such that then it will encourage more manufacturers to come in.
You mentioned there that the lap times that should be similar. Is that going to be sort of by the end of the season, do you think, or are you envisaging straight away that you should be on the pace in terms of this year's lap times?
I think it'd be very interesting to see, actually. I think in
some might.
Yeah, in 9 months' time, it'll be there's lots more development in front of us at Mercedes and Ferrari and Renault, and all three organisations are working hard to get the highest thermal efficiency and make sure that our energy recovery systems are working as efficiently as possible, and as well as the impact on the car as well.
Yeah. And James, there's obviously the engine and powertrain department that's looking after all this new technology. Surely it's going to be a huge step to actually integrate all of this into a race team and have it functioning as it should on a race weekend.
Yeah, it's quite daunting. You mentioned that we've been working on it for a few months. I think most teams have been going on it for about 2.5 years. So it's by far and away the biggest step in the sport in my career, and I suspect in the history of the sport in terms of the size of the change. The rules are changing across the board. It's not just the powertrain, the aerodynamic rules are changing, the transmission rules are changing, and the powertrain. Absolutely epic changes there. I could talk for hours about the impact that this has on the car. I won't, but I'll just give a flavour of it in terms of just the effect it's going to have on the cooling system. We've had broadly the same engine, almost identical engine since 2007, 2008, can't remember exactly which year. And for the first time in 5 years this year, the car that I was involved in was launched to the track, ran at the first race and ran at the next few races, and we didn't need to change even one row on any of the radiators. So there's an oil cooler, a water radiator, a hydraulic cooler, and a gearbox oil cooler. And for the first time in 5 years, we didn't need to make an adjustment. That's because finally we got the balance of airflow through all of those coolers correct. And we did that off the back of several goes at it over the last few years. On an engine we know extraordinarily well, on a set of regulations that have been stable for some time. Now, for next year, the baseline shifts completely. Not only do all of the heat levels that are put out to the oil, the water, the gearbox, the hydraulics, not only do they change in their balance relative to one another, but the overall loading on them goes up massively. We have to introduce a whole new cooler, the intercooler, to cool the charge air down from in between the compressor and the engine. And that's a massive lump to put in the car that just isn't there at the moment. The energy recovery systems that we've been talking about, not just the motors for them, but the power electronics that go with them, and the batteries that store the energy temporarily for them. All of those require significant amounts of cooling, and the overall cooling load for the car is much higher. So just working out where all these coolers are going to go in the car, working out how to distribute the airflow into them such that you get exactly the right amount of airflow in each cooler, such that you keep all of these bits of the car in fairly narrow operating windows temperature-wise, and where we don't have the luxury like we do on a road car of putting a big radiator in and then having a thermostat to control the temperatures. where you have to get it exactly the right size and then make sure that, that the temperatures stay correct from that. That is a massive challenge, and one which every single chassis designer in the pit lane will be justifiably terrified of, one which every single team will be at least mentally girding their loins for the fact that, having run the car for the first time, they will count themselves lucky indeed if they don't have to make some furious adjustment to some of the distribution of the flow around the car, and where they will have done a very good job if they have brought a car to the track which is on the weight limit. For the last many years, we've had stable regs which, they're not easy to get a car under the weight limit, but you can do it, you know you can do it, and you know that you can have a sensible amount of ballast to get the car behaving as it should do on the track. For next year, that is a significantly bigger challenge. The technology that's going in the car to improve its efficiency to the point where we can get the lap times where they need to be with much less fuel, it's heavy. And we need to make sure that, that we've done everything we can to bring that extra technology into the car under the weight limit. And it's a big, big challenge.
Right. Now, Gordon, you've been dealing with these problems in the real world at Williams Hybrid Power. How much crossover really is there from motorsport into the real world? Because, I mean, some of the projects you have at Williams Hybrid Power are so diverse that you're almost scratching your head thinking how they do relate to motorsport.
Well, so at Williams Hybrid Power, we design and develop electromechanical flywheel energy storage technology, competing, let's say, with supercapacitors and batteries. And I should say that that technology was brought to Williams for Formula One, but in the end actually did not race in 2009. However, we have a motorsport program ongoing with Audi Sports for Le Mans, and the technology is very much used there in anger. The technology developed in motorsport, the white heat of development, has real applications in the world, and specifically WHP is focused on buses, city buses and city trams. So allowing on buses, for example, a 25% or greater fuel save as verified by our demonstrator bus program. So it's all very exciting and has the possibility to make a big impact in the wider world. I would say that cost is king still, and so the cost down potential of a technology is extremely important when one's facing the wider world, but technology fit is also extremely important, and hence this focus at the moment for us on buses and trams, where the start-stop nature and the high mass of the vehicles particularly suit the technology.
And because in Formula One, you know, you're looking for power, you're looking for speed, lap time. I know some London bus drivers who are looking for that I've been on, but it seems to me that it's very different, because buses, you're not looking for that immediate power, you're not looking for speed, but the technology is obviously very much transferable.
It's very relevant, and what you're looking for in both cases, on the track and on the road, is thermal efficiency, really. And it's just been explained how important that is and will increase both in Formula One and in sports car, where the regulations are moving towards an allocated amount of energy or a fixed flow rate, etc. It's the thermal efficiency which is particularly relevant as well to saving real fuel and reduced emissions on the road, and ultimately the business case for the end user, which is extremely important to adoption of the technology.
James, correct me if I'm wrong, for next season, the Formula Ones, they can harvest 2 megajoules, but they can use 4 megajoules a lap, up to 33.3 seconds. Now, does that mean you're going to have to harvest for 2 laps for a qualifying lap? And, you know, how's all this going to work in a race?
Well, it's a little bit fluid. You can use it as you wish to within the rules, but typically in racing mode, you're going to be operating in a sustainable fashion where on every lap you're harvesting the same sort of amount as you are then using, so that there's an equal inflow and outflow. However, in qualifying, where you don't have to operate sustainably and you can just have an orgy of discharge with the 4 megajoules, then you can charge the car up in the out lap or the in lap from the previous qualifying run and the out lap of the next, and then go nuts in a qualifying lap where there can be a big mismatch between how much you're harvesting on that lap and how much you're then using.
And will it have an effect on overtaking, or are you going to have a problem if you're not using the energy recovery systems? You're not going to stay with the person in front of you, so you can't store it up over a lap and a half and use more of it for a longer time to get past someone during a race?
Well, this is something that's vexing all the teams at the moment. Exactly how the strategic balance of the races is going to change with these systems is something which we have some idea of how it will work out, but there's a lot more thinking to do between now and the start of next year, and then I'm sure that once our plans actually get exposed to the enemy for the first time, they'll all need to change again. But typically, all of us will be trying to produce cars whose thermal efficiency is such that you can race carefree with the 100 kilos that you've got, with an engine that's able to operate at this 100 kilo an hour flow limit and the 100 kilo total for the race, and you can just use that up. But almost inevitably there will be tracks and circumstances in which you're having to eke out your fuel a little bit more than you might wish to be, and someone else might find themselves in a slightly more favourable circumstance, having maybe followed another car closely for a number of laps and saved some fuel, which will allow performance differentials to build up, which will then affect the way in which you overtake. Or indeed, you may wish to spend some of your energy budget a bit earlier on to get ahead and then pay for it later on in the race. So there'll be an ebb and flow that will be interesting for the teams and the fans alike to get on top of.
But we're not going to be staring down the barrel of a fuel efficiency formula.
Well, it is a fuel efficiency formula in as much as the cars...
But just cruising, and like we have now with the Pirelli tyres, people are just saving the tyres. Are we going to have long spells at the end of a race when people are just constantly saving fuel, or is...
Well, I would slightly reject your analysis of what we have now. What we have now is pretty much just racing as we've always had it. Right. The cars in races are always being looked after in a manner that they're not being looked after in qualifying. And the idea is to do the race as fast as possible. And the same will be true in 2014. I suspect that there will be more incentive to follow someone early on in the race than there might be at the moment.
Okay. But, right, we're going to use our first voting card question, which should be coming up on the screen very soon. The question is there a place for hybrid technology in Formula One? And press 1 if you think there is, and press 2 if you think there isn't. And we should get a countdown clock that takes us down to how long you've got. There we go. No countdown music, but we do have a countdown clock. Right. And we should now have, there we go. I think that's overwhelmingly yes. There is. I don't think there's any surprises after listening to these three for the last 10 minutes. Now, Andrew, we were touching on this earlier, and clearly, looking at that, there is a place for, well, we all think there's a place for hybrid technology in Formula One. What can we do about trying to relay that to the broadcasters and relay that to the general public? Because I remember I came up to Mercedes, I think a year ago, and you told me this great story, which you can tell everyone now, about Schumacher using his KERS to overtake plenty of cars, but no one knew about it. Mm-hmm. Are we going to have that problem? And how can we sort it?
The story that you're talking about, Ed, was the Indian GP a fastest lap KERS deployment profile is always created. And that's what you'd use during a flying lap of a race where you're not being attacked from behind to lose your position and you're not trying to gain a position. At the start of a race, it's very much down to the drivers as to when they use KERS in traffic, and Michael very wisely saved his KERS deployment up until he was on the long straight, and deployed the whole 400 kilojoules in one go, and got past about 4 cars. Nobody knew about this apart from maybe the cars that he'd gone past, where they thought, crikey, he's got a good run out of that corner. But we showed the bit of footage with our in-car data, recorded data. So that's an example where actually it would be more beneficial to show the world what's going on and what the drivers are doing and what the engineers are proposing as options. For 2014, there's a lot more energy management to deal with, as James mentioned. Perhaps we should be looking to remove the rev counter from the display that we currently have on the TV feed. Perhaps we should be replacing that with the instantaneous fuel flow. So through corner, it's going to be low, close to zero, and as soon as the driver isn't traction limited, it's going to be up to the 100 kilograms per hour. Perhaps that's more representative of where we're going. I think it's something that the FOM and the engine manufacturers and the teams need to work together on, and come up with something that helps explain the sporting spectacle that we're presenting. Of course, there's always going to be people where they're saying we don't want to show that information. That's sensitive, but I suspect there need to be a little bit of compromise where we do show perhaps a little bit more than we're all comfortable with, but to help explain what's going on in the sport, but without making it too complicated. And at the end of the day, it's a motor race, and the fastest, most efficient motor vehicle will win that race.
Well, we touched on the spectacle there. We've got the second question for our voting cards, and this one: does engine noise matter? I think Max Mosley thinks it doesn't. Again, 1 yes and 2 no. We've got more responses this time, so I think more people are getting the hang of it. Interesting, it's not actually as overwhelming as I thought it would be. James, was that a surprise that so many say no?
I've not really ever thought about what other people should think about this topic. For my own part, sitting at the start of a Grand Prix with all the cars giving off heat haze and making a hell of a row, I find very exciting. So I think, although it's noise is just lost energy, it's still exciting, and so I would personally like it to stay noisy. However, I don't think that that the engine noise that we will have in 2014 will be in any way unexciting. I think it'll be plenty loud, and people will find it so.
It's good for all us enthusiasts, I think. Gordon, you touched on it earlier. You mentioned your sports car program. They work to a very different set of regulations. How different is the hybrid system that you're using on that car compared to what Formula One is looking at next year?
Okay, so in terms of power, it's unlimited. In terms of energy used per lap or available per lap, in 2014 it's going up to 8 megajoules, which is double Formula One. And of course it must last 24 hours, which is a lot longer. So in these ways it's it's a bit different than Formula One. I would say the 2014 regulations for sports car are very much focused again on thermal efficiency, and so there's alignment with Formula One in that respect. The hybrid system has more authority over lap time than ever before, and that's exciting. Also, we're up for something interesting in 2014, which is a true battle of the hybrid technologies, with Porsche returning again, and allegedly with their battery system. And you've got Toyota with supercapacitor and Audi with electric flywheel. So it's going to be very interesting in that respect, with relatively open regulations, to see how the technologies get on against each other.
That must be a much more exciting environment to work in when you've got so much more freedom, or is it? Or I suppose there's also a huge amount of nerves as well, because there's so many options. It's easier to pick the wrong one.
Yeah, I think freedom is exciting for an engineer. That said, there's plenty of freedom within the main formulas within motor racing, including Formula One. So I think that would be my viewpoint.
Well, third question for the voting cards. Now, here we go. Do you believe F1 should work to a budget cap in the future? There's, again, 1 yes and 2 no. It's obviously a very tricky thing to actually do, a budget cap, especially with some of the teams. But it may well be the answer to technological innovation. What do we have? Interesting. I would have thought with a room full of future engineers that it would have been a higher percentage yes. Is a budget cap workable in Formula One? Can you actually stop teams spending money, or hiding money, perhaps, is the better phrase?
I think we all run our lives out of work to a budget cap, and I think it's therefore possible to run our working lives to a budget restriction. And I think all businesses do actually have budgets that are set over their financial year, and that their management work to monitor that, forecast where it's going, and try and stay in on budget. So yes, it is doable.
And you don't think that so I won't name any teams at all, but perhaps those that make road cars, they could maybe put some wind tunnel testing down to the road car department rather than the Formula One race team, or is that?
No.
No?
The size of the conspiracy you have to maintain is just too big. Teams are big. There's a lot of movement between the teams, and aside from the fact that it's just cheap, and people are just not in it for that, we want to compete to the rules and win within the rules. Aside from that fact, even if you were Machiavellian, the number of people you'd have to bind into you to try and maintain that conspiracy, it's not plausible.
Yeah. And well, moving on to the drivers, with all these new technologies coming in, James, will the elite rise to the top with the drivers? Will we still see the best drivers winning, or is it going to be more of a technical exercise in actually using all these hybrid systems at the right time and in the right way?
Well, I think that I find it almost inconceivable to imagine a set of rules where the best drivers would not prosper, and they would be the same best drivers under any set of rules. They're just gifted car handlers. But I actually think that the rules for 2014 will probably unburden the drivers somewhat compared with the current rules. The current rules for harvesting and discharging Kerr's power are a little antiquated, to say the least. They have to be done entirely under the driver's control. And he was mentioning the optimum release pattern that we calculate beforehand. That's so easily automatable, and yet the drivers have to remember how long to press the button for in which bits of the track is. And then the control under braking of the way in which the machine harvests the energy is, again, sort of open loop and controlled by driver switch settings. in 2014, the delivery of positive torque to the wheels to accelerate the car and negative torque to brake the car are dealt with by the right and left pedals. So the accelerator is a go forward type torque demander, and the brake pedal is a slow down torque demander. And on the brake pedal, there are different ways that the car can get its braking. There's engine braking, there's hydraulic, there is the electronic braking that comes to the hybrid system, and there is also the actual hydraulic discs and pads. And those three actuators to generate negative torque are all dealt with by an arbitrator that will just say, well, the driver wants this, and it will choose which of the three are the right way, and the mix of the three to look after the car in the best way possible. The driver fully in control of the amount of torque he's requesting to decelerate, and therefore in control of whether the brakes lock, whether the wheels lock, but the car managing the flow around the car in the right way. And that's actually a better and more sophisticated way of doing it. It's a way that mimics better what happens in the real world in road car land, and hopefully will allow the drivers to drive the car a bit more unfettered by switch settings.
Well, let's ask the floor. This is our final voting card question. Do you think the importance of driver skill will be lessened by this increase in technology? Again, 1 for yes and 2 for no. I think if you all found James as convincing as I did, it will probably be overwhelmingly 1 rather than the other.
I hope 2.
Yes, 78% of a good job. I think that's called. Andy, coming to you quickly, we've been talking a lot about these 2014 regulations. As we all know, these regulations never last forever. Where do you see Formula One going further into the future? Is it going to carry on down the hybrid route, or is it always now going to be linked to road cars, and depending on what that sector's doing?
I think initially we shouldn't underestimate the introduction of the new regulations for 2014. And as James said, it'll be a year of a lot of change as people get airflows right and torque arbitration systems to work well. So I imagine that that will spill over into 2015 in terms of the amount of change and ideas flowing around. From the manufacturer's side, we believe the regulations will stay largely the same all the way up to 2020, with a ever decreasing amount of freedom of change on an annual basis. Feels like a long time to 2020 at the moment, but I'm sure it will go by very, very quickly. And the opportunity to develop technologies that, because the fuel flow aspect is aligned with the road car side, I think we'll see an awful lot of technologies spin off towards the road car world.
Okay. And Gordon, talking about the future, a new championship for next year, the Formula E Championship, which is completely electric. Very, very new, obviously. And Williams, I've just had a press release land in my inbox. Williams is working with Formula E.
Yes, that's true. Williams Advanced Engineering is working with Formula E and supplying the battery and battery management system to Spark Racing Technologies. So that's all extremely exciting, and really builds off of our focus on all aspects of the kinetic energy recovery system, not just in Formula One, but outside of that.
And are these cars going to be very quick? I mean, we haven't heard that many details about them. I mean, where are they going to sit in the sort of ladder of single-seaters?
I must say, I'm no expert on the matter, and I'm very much focused on Williams hybrid power and the electric flywheel. It's difficult for me to comment properly about that. Yeah.
James, what's your opinion on the Formula E Championship? You were just mentioning then that as all the cars line up on the grid and you love the noise. Does an entirely electric championship send shivers down your spine, or is it quite exciting?
Well, I'm a bit of a Formula One bigot. I sort of only like Formula One, and I'm interested in Formula E in the same way as I'm interested in the fact that there's a bunch of people now starting to make electric aeroplanes. I like light aircraft, and there's people now starting to make self-launching gliders which are electric powered, and some hardier souls that are trying to make some sports planes that are electric as well. You know that it's right at the edge of what's doable at the moment, but you also know that 3 or 4 years ago it wasn't doable, and that in another 5 years it'll probably be quite exciting. But I'm interested in not in a sort of professional way like I am in Formula One, which is my main focus.
And Gordon, I was talking earlier, this technology that's coming to Formula One that we just heard from Andy, that's actually going to take quite a few years for it to settle down and everyone to get their heads around it. How long does that kind of technology take to transfer into the road car market? If I go to my local dealer, when am I going to see this kind of technology on road cars? I know there's bits and pieces now, and it usually filters into supercars first and then on down the food chain. But is it 10 years? Is it 5 years?
I would say 3 to 6 years, but I'm thinking most closely at the moment about getting this technology, electric flywheels, onto buses. And so if that's still relevant to your question, then focused on Formula One in 2009 and on city buses, and beginning to ramp up to sell in volume end of 2014, early 2015. So that sort of time frame.
And you said earlier that the biggest hurdle is cost. Is that's surely going to improve over the next few years as these technologies get cheaper to implement?
Yes, and certain technologies have, let's say, better cost down potential than others. But certainly other rules apply, such as the manufacturing cost curve as you increase volume as well. Yeah.
Now, we're going to open the floor to questions in just a second, but I was wondering if you could be very kind and pass your voting cards down to the end of the door. Apparently, they do have a habit of walking off. I'm not sure what you need them for, because they don't do much at home, I don't think, but do please pass them down. Right, so now if anybody's got a question, we'd love to hear it, as long as it's obviously related to the future of motorsport and not a job application at this time. We do have a roving mic, I think. Do we have a roving mic? Well, we could probably do without one, actually, because there's only a few of us. So do just raise your hand, and we'll try and get through as many as possible. Yes, in the middle there.
Question to everyone, I guess, but I was thinking of James in particular. All this new technology we've heard about coming in 2014, and obviously it's the first year it's going to be in action. Are we going to see all the cars getting to the end of a race, or is it possible we're going to have a high attrition rate and half the cars are not going to finish?
James.
Okay, reliability, which is what your question's about, really. That's an easier problem than speed. And all of the engine manufacturers will be making sure that their engines are within a certain operating window, capable of running the sort of kilometres that are necessary to get to the end of the race. Dynos for doing that are reasonably good. It's expensive to get these engines to that level of reliability, but I'd be surprised if any of the three main manufacturers were going to drop the ball on that. Similarly, transmission units, the gearboxes, the teams have pretty good rigs for doing that. Again, dynamometers that allow us to run the gearboxes and prove that they can do what they need to do on the track with proper track replay, real gear shifting, and all the things that happen to them on tracks. So I think that we probably go into the season reasonably hopeful that the powertrain is going to be able to deliver power for the duration of the race and the next race and the next race, because it doesn't have to just do one. But whether or not each of the manufacturers and each of the teams will have made the right mousetrap such that their car is competitive or not, that's, I think all of us will just be holding our breath until those first tests and that first race to find out whether the compromises and the design directions that we've taken will prove to be the right ones.
Great. Another question, just at the front here.
Can we use?
Oh, we now have a roving mic.
Please, microphone.
It's a question for Andy. You said at the beginning you were talking about thermal efficiency, and I think also we need to concentrate on road relevance. Now, a lot of what we've been speaking of is the wasted energy that we're recovering through heat, through braking, etc. But also, I think equally important is the using the most of our 43 megajoules or whatever that we get from a kilogram of fuel. And I think that the 2014 engines, the IC side of it, is heading, sub 240 grams per kilowatt hour or whatever, which is certainly equal to many road cars. But I think the big difference is that road cars need to achieve it at part throttle and racing engines at full throttle. Does that diminish the road relevance of what's happening with the IC part of the equation?
Let's just point out this Pat Simmons from Russia.
I spotted him.
You knew there was a question coming, didn't you?
I think the duty cycle of a Formula One engine is very much different to a road car engine. But where road car technology is going is that with a hybrid system, the internal combustion engine isn't running at the traffic lights. That's happening today with stop-start technology, and perhaps it will be the launch from the traffic lights, if you can say that, with regard to road cars. That will be internal combustion engine augmented by the hybrid system. At which point I think the duty cycle of the internal combustion engine in road car will tend towards that of Formula One. We will end up with systems where the internal combustion engine is running at a more thermally efficient full throttle operating position, and the electric machine with the capacity of the storage device, whether it's a flywheel or a battery, will fill it in. And that's the way road cars will get more and more efficient going forward. So I think it is relevant, and I think it's something where the energy schematic that we've got for Formula One from 2014 is where we will see road cars in 5-6 years' time.
Does that answer things? Another question on the right over here. Oh, actually, if the microphone's there.
Oh, hi. A similar question about reliability. What's the opportunity for increased testing for next year's regulations? Will you be able to do more testing? I can't recall what exactly is going to be allowed. Could you explain a little bit about that?
There's a debate ongoing at the moment as to what the testing will be for next year. So I think over the next few weeks that will become clear to us all. As James mentioned, though, there are sophisticated dynamometers for testing the powertrain, and as long as James has got his airflow distribution right, then everything will be okay.
Right, another question. Sorry, there's one over here.
Yes, you've got three manufacturers got now quite complex new technical regulations, whereas in the past it was just a straight internal combustion engine, various hybrid systems, etc. To what extent is there a likelihood that the three manufacturers will go different routes? And if, having done that, one of them ends up completely off the ball, what opportunity will there be for them to catch up? Because at the moment the regulations are fairly difficult in terms of engine development.
One of the things that was discussed and chaired by the FIA with the manufacturers was we want to leave freedom where we think there's good thermal efficiency potential, but on some of the things like the exact bore size, crankshaft centerline height, those are completely prescribed in the regulations, and I think there's just over 40 extra definitions in the 2014 regulations to try and constrain the development opportunity, but leave freedom in the areas of high thermal efficiency potential. So some of the quirkier options have been removed. If we end up with a difference, then what's been discussed is to put in the sporting regulations that a manufacturer can change on an annual basis. So you'd homologate the power unit at the start of the season, the end of February, 5 to that specification per driver, per championship, and the allocation you can utilise as you see fit for the chassis you're providing to, and only reliability updates through the season. So if a manufacturer's got a big problem through reliability on the first power unit, you're not tied into that. From a performance perspective, then it's an annual opportunity to change.
Right, there's another question at the front here. Oh, sorry, yeah, we'll go for that one first.
Is there going to be any tyre changes or make them last longer?
One for you, James.
I'm not. I'm currently doing a lot of gardening, so I'm slightly away from the coalface at the moment. But I'm not sure exactly what the state of the tyre contract is for 2014. But I honestly don't expect that there would be substantial changes away from the direction that we've had in the last couple of years.
Someone with a microphone, yeah.
I'd like to ask James about the innovations in Formula One, because I see that FIA is not very friendly to those innovations. Like, they're banning the passive double DRS system this year from last year, because I think innovations is very important. So I'm wondering, what do you think is the effect of innovations in Formula One on the road cars or the aerospace? And do you think the regulations should encourage more innovations in Formula One?
Well, I actually think that there's loads of innovation in Formula One. I'm fairly sure that anyone who's worked in the sport would agree with me. I doubt whether many of us would feel that the FIA had been unhelpful in that regard. The sport is about trying to find every single possible way that you can find to make the car beat your competitor cars. And the very fact that we have a rule book forces us to be innovative. It makes us strive for new ideas that maybe someone else hasn't thought of. And if, we have an idea and it flourishes briefly and then is banned, well, so what? That was good. While it lasted, hooray. And now we've got to find a new idea. If an innovation stays on the car for more than a couple of years, well, it's just boring old hat. Everyone's got it by then. There's no relative competitive advantage, and it's not interesting anymore anyway. So personally, don't feel any frustration about it. I've got lots of examples of where the sport has brought in a new regulation, and that new regulation has actually forced us to think about the way we go about our business in a different way, and we think of a new way of attacking the problem that actually we could have thought about the year before if we'd only been mentally unlazy enough to do so. But the very fact that you've introduced the regulation is like goading you all the time to think of ways to improve the thing. So no, I don't think it's unhelpful. I think the sport's absolutely stuffed full of imaginative engineers who are bringing innovation to it. And really the only thing that is difficult to do is to strike the right balance between how brave you're prepared to be within innovation, because they always come with technical risk, and yet have the right balance between the risk it incurs and the possible advantage it brings.
Very good. We got, one down here.
Yeah, question for Andy or James. What was the reason for deferring the electric power only in the pit lane for 2014 to sometime in the future?
The reason for delaying it to it's currently being talked about for 2017, that sort of time frame, was a sense of that there's already a lot going on with the regulations. So defer it for a few years, allow the more efficient internal combustion engine to be championed initially, and then bring that in later on.
Okay.
I hadn't heard of that as a reason, so good point.
And I think from a casual inspection of the rules saying, let's have an electric pit lane, and people go, oh, that sounds like a good idea, let's do that. And then you start thinking of all the difficulty of doing that, and it multiplies very quickly for something which, yes, would have had a certain amount of cachet for the sport to be doing this, to have an electric pit lane, but tremendously challenging technically, and probably just biting off a little more than we could chew in a year where we're already chewing an elephant.
It's a great phrase. It's another question. Yes, I must ask that we use the microphones actually, because otherwise the webinar people will not hear it. Is there a microphone being passed down? Oh, right, okay. Nice. Yeah, sorry. Sorry? Oh, right, okay. Well, if you go first, and we'll come to you in a second. Sorry.
Yeah, Darson from Go Ahead Group. This is a question for Golden. You mentioned that obviously you're working on projects which is already bringing in technology that initially started from F1. Unfortunately, our understanding, because I'm from the bus industry, how far is it from being, you said, of 2015, in terms of from Millbrook testing, in terms of fuel efficiency, how much savings is there compared to a normal diesel bus that you're seeing?
Right, so, Millbrook testing is near and dear to us at the moment, and we're looking at achieving a low-carbon bus certificate, and so that's part of our activity at the moment with our demonstrator bus. But if I say at the moment upwards of 25% fuel save, and that's borne out as well on a real-world route.
So that's on the London test route?
That's right, yeah. So this is a London test route marked out on a proving ground, and it's upwards of 25% fuel.
And when you say about the low carbon thing, would that be equivalent to the Euro 6 or so? Would you be able to bring in a product which will equate to Euro 6?
It would allow an amount of subsidy. I think it's 6p per kilometre to the end user. So it would just add that extra incentive in terms of the business case.
And will you be looking at retrofitting rather than producing a complete product?
Retrofitting is very much in our line of sight because the technology is quite packageable, small, and can be fit in a number of places. So we're looking at retrofitting of existing fleet as well as new build.
Okay.
Thank you.
Thank you. If we could pass the microphone down to the third row. Yeah. Thank you very much. We've probably got time for another 3 questions, I would have thought.
Just a question for the panel in general. The OEMs are now beginning to concentrate much more on embedded energy issues and carbon commitment in building the vehicles. Can you see Formula One also going in that direction as a result of that, and how would that pan out?
Andy, do you want to take this on?
I think the efforts are very much focused on the thermal efficiency of the power unit on track in qualifying, etc. The The way we run all our businesses, though, up at Brixworth, we do focus very much on the energy efficiency of the way we operate the business. Going forward, how will that pan out? Will that evolve into a Formula One engine power unit manufacturers initiative? I'm not sure, but perhaps.
I think certainly at Enstone, the Lotus team, the factory itself is run as well as we can do from an energy footprint point of view. But the sport as a whole, from what I understand, the sport as a whole has been offsetting itself for years by planting trees. From what I understand, the FAA has been taking that initiative. So if the technology we're taking with our cars itself is a helpful one and mimicking or going down the same sort of path that the road cars are headed, that's good. The individual teams are themselves operating, we hope, in as good a way as possible, and then at a top level the sport is offsetting its carbon footprint as well.
Thank you.
Okay, we've got another... Sorry. Oh, right. Great. It works. We have people watching.
Okay, we have a question from Ganesh. With the presence of high voltage systems in the cars, are there any significant changes in safety rules?
Andy,
I can, ever since the first race of 2009, we've had high voltage systems on the car, and when we were developing the Kerr system for 2009, we took that very seriously. We have a safety policy that we operate under for our design, and we also get an external company to do a safety case on the design of the system and the validation that we need to do before we go racing, and that's something that is carrying on for 2014. No change in terms of the voltage and the safety aspect. Turbocharger though on the car, so high pressure direct injection system where we're using the same technique to make sure it's safe, and also analysing the energy stored in the turbocharger to make sure that the whole power unit is safe.
Should we have one more question from the webinar?
Okay, one from Aaron. Are there any concerns about the reliability and durability of the new MGU-H technology, for example, electrical machines in high temperature environments?
We touched on this one earlier, I think.
Well, I'm sure Andy can dispatch it.
Thought James was going to save me then. So the MGU-H, so the motor generator unit heat, is the device that's allowed to recover energy from the exhaust stream via the single turbine. The turbine and compressor must spin at the same speed, maximum speed 125,000 RPM, and the MGU-H must be directly coupled to that maximum shaft speed. Turbochargers tend to be very hot. Electric machines run more efficiently if they're nice and cold because of the copper losses as it gets hotter. Magnets tend to lose their magnetism at a certain point if they get too hot. But it's just another technical challenge for the engineers to manage. Just like in 2006 when we changed to quite regular piston alloys from the exotic ones that we'd been using in 2005 and earlier. So it's a group of motivated competitive engineers looking at these technical aspects, balancing it up using industry experts and coming up with an installation that they feel is safe enough such that it'll operate at a good performance level, survive for 5 power units per driver. So it's a good question because it is a difficult area, and James has got every confidence that none of the manufacturers are going to put a wheel on the grass. So we'll know in 9 months' time, have an indicator.
Right, one final question from the floor. So right here, got a microphone ready. That's brilliant.
Hi, my question's directed at Andy and James. So when considering these extensive energy recovery systems, how is it going to affect the winning strategy employed on slower circuits like Monaco? And also when considering the constraints on cooling, how is it going to affect this aerodynamic design of the wing profile on this circuit?
Who would like to step up?
I can do the first bit on the power unit. So the peculiarities of Monaco, it's a short lap, but the regulation in terms of the energy are per lap. So the 4 megajoules deployed per lap means that the percentage of time that you can deploy is close to all the time that you want to. And also energy recovery is relatively easy because there's an awful lot of braking events. And 100 kilos of fuel is still the allowance even for Monaco, so not a big challenge there.
On the chassis side, the regulations do put a certain amount of pressure on needing to increase the aerodynamic efficiency of the car. We can't afford to run quite as much dirty downforce as previously, but it'll just be fairly similar to the challenges of previous years, where you'll have a certain amount of lift, a certain amount of drag, and you'll simulate whether adding lift at a ratio of 3 or 2 or 4 to drag to that operating point will make you go faster or slower, and then you'll choose the rear wing setting that is optimum for doing that, having simulated it. So the challenge on the chassis and wing side very similar.
If I could just ask one question myself, Andy, looking ahead to next year, 2015, you're supplying McLaren next year, but then come 2015, Honda is supplying them with engines. How on earth are you going to handle your contractual obligations without giving too much away to Honda?
As you mentioned, it's a contractual obligation. McLaren have been a customer to Mercedes over the last few years, and we'll continue to operate in the same professional way, where we do the very best to look after the work Silver Arrows team and also the customers. But as ever, with anybody that we deal with, we've got confidentiality agreements that we respect and that we know that McLaren respect as well.
Right. Very good answer. We really must end because we've gone over time as it is. Before we do, we are missing 6 voting cards. So can you please have a look around? We have a few here, obviously, but we're missing a couple more. So if you can see one on the floor, then please do give it to us at the end. Now, I just want to say thank you so much for Formula Student organising this evening along with Motorsport Magazine, and to my panel here, a big round of applause for them. Thank you very much.